of rigid bodies. Let's say over here there is a rod, massless rod, which is supported over here at support A and B. These are two supports. This is 10 meter. For convenience, we are taking very simple values. And let's say in the middle there is a force of 200 Newton. So it is in the middle. So it means 5 meter is this way and 5 meter is this way. We are asked, that is, what is the force A and B that will experience if these are two supports they are there. By common sense, we can say that is obviously it is in the middle, it is not towards one of the ends. So obviously the force which is going to be experienced by A and B will be same, and this is going to be 100 Newton. So we know the answer through common sense only. Now let's use the concepts of physics and come to the answer, that is, it should come as 100 Newton and 100 Newton, so that we know that is this is the right answer. So for that, what we do is, when we apply a force like this, we see two things. One is it is in translational equilibrium. That is, this body is neither moving along x-axis, nor moving along y-axis, nor moving along z-axis. So this is in translational equilibrium. That is, the net force along x-axis is equal to 0, along y-axis is equal to 0, along z-axis is also equal to 0. So this is about the translational equilibrium. Now let's talk about the rotational equilibrium. A body is in rotational equilibrium if there are some forces which are trying to move it in the clockwise direction and some other forces they are trying to move it in the anti-clockwise direction about the same axis rotation. Please understand, you cannot change the axis midway. If you have chosen some axis and the body is not rotating about that axis, it means about that axis clockwise movements is equal to anti-clockwise movements. And whether you say clockwise movements or you say torque, that is one and the same thing, right? Torque is also moment of force also. We know it as a moment of force, that is force into perpendicular distance between line of force and axis of rotation. So torque, either you say torque or you say moment of force, be it clockwise, be it anti-clockwise about one axis. That is, if the body is not rotating, it is not alpha. Rather, I think that is more precise. That is, it shouldn't have any angular acceleration. It means this is in rotational equilibrium. It may be stationary or it may be moving with a constant angular velocity. So that is in rotational equilibrium. Over here, this is, we are talking about statics. So this body is stationary, this is not moving. So it means this is, when you say it is translational equilibrium. Let's draw the force diagram. So first let's draw the force diagram. This is a rod. This is support A, this is support B. This applies a force A over here. This experiences a force A. To have reaction, there is equal to opposite reaction. This support applies force B, experiences force B in this direction, and in the middle there is a 200 Newton force. This is 5 meter and this is also 5 meter, right? So we have done our first job, that is drawn the force diagram, that is free body diagram. Being good at free body diagram is a prerequisite to understand rotational mechanics properly. So over here we see that is this body, this rod is in translational equilibrium. Translational equilibrium. It means what? It means summation of forces along axis is equal to 0. That is, net force along axis has to be equal to 0. And we see over here that is obvious there is no force along the x-axis though. So let's consider net force along y-axis also equal to 0. This rod is neither moving up nor moving down. So net force along the y-axis, that is also equal to 0. So net force along y-axis is also equal to 0. It means that is the upward forces, they have to be equal to downward forces. It means upward forces on to this rod. Fa plus Fb is equal to 200 Newton. So we get one equation, right? We have two unknowns, Fa and Fb. So somehow if we can get two equations, our job is done. Then we know that is this rod is not rotating about this axis, that is torque about A is equal to 0. When the torque about A is equal to 0, now let's see what are the forces we are acting on this. One is Fa 200 and Fb. So when we say torque about A is equal to 0, let's put nail into this. Now this is, we are considering torque of all the forces about this axis. Torque of this force, if there is a point about this axis, is going to be equal to 0, because torque is force into perpendicular distance between line of force and axis of rotation. Axis of rotation is here, line of force is here, it is passing through that only. So torque of this Fa about this axis, about this point A, that is going to be equal to 0. Now we have two other forces. One is 200 Newton, the other is Fb. If we look over here, this 200 Newton, let's say if we have nailed over here, and if you apply a force in this direction, let's say 200 Newton, this is going to push it this way, trying to rotate this way. And this force which is being applied in this direction, this will try to rotate it this way. So 200 Newton will try to rotate it in this direction, and this Fb will try to rotate it in this direction. But this body is not rotating about the point A. So this is in rotational equilibrium. There is no net torque about A. So it means about A, clockwise movements, they have to be equal to anti-clockwise movements. This is clockwise movement which is trying to rotate is of 200 Newton. So it means 200 into 5 is equal to FB into the distance from the same axis, about A only we are talking about. So 5 plus 5 into 10. So FB comes out to be 20 to 5, that is 100 Newton only. So if FB is 100, we put it over here, so FA also comes out to be 100 Newton. So that matches with our common sense answer. Let's write some more equations about the torque so as to understand it better. If we are interested in finding the torque about B, obviously torque about B is also equal to 0. Net torque about B is also equal to 0. Now, FA is the force. Now, the FB, the torque of this force about this axis is going to equal to 0 because the axis here, this line is also line of force, is passing through the axis only. So that's why the torque of this force about this axis is equal to 0. It has been hinged over here. Now it has been hinged over here. The force is being applied on the hinge itself. There is not going to be any rotation. So now there are two forces. One is FA. It is trying to rotate this way. And this is 200 trying to rotate this way. This rod is not rotating in this direction nor rotating in this direction. So clockwise movements is equal to anti-clockwise movements. So over here, let's say this, when we say about the clockwise movements which is trying to rotate it in clockwise direction, it is FA into 10 should be equal to, this is 200 into 5, right? So this once again, FA comes out to be 100 Newton. We get the same answer. Please understand that is if there is some rod and someone is applying a force of suppose 20 Newton onto this, and it is asked whether this will produce clockwise movements or anti-clockwise movements, we cannot say anything because it depends on the axis rotation. The movement of this force about this axis is going to be in this direction, that is anti-clockwise direction. But if we change the axis, if axis over here, now this force will try to rotate in this direction, that is clockwise movements. So if someone asks what is the direction, whether it is clockwise movements or anti-clockwise movements, we have to be aware about which axis we are talking about. In the whole rotational mechanics, axis is very, very important. Whether we talk about the moment of inertia, or we talk about the torque, or we talk about the, let's say, instantaneous acceleration, etc., etc. The axis of rotation plays a very crucial role in rotational mechanics.